The morning briefing at the Reich Air Ministry in Berlin on September 15, 1943, began like any other wartime intelligence session until Oberst Hans-Joachim Marseille placed a folder marked Top Secret on the conference table. Inside were reconnaissance photographs and production reports that seemed to mock the laws of industrial physics. American aircraft factories were producing complete military planes at rates that exceeded one aircraft every 6 minutes, around the clock. Gentlemen, according to our intelligence sources, the Americans have now produced over 100,000 military aircraft since Pearl Harbor, Marseille announced to the assembled Luftwaffe officers. At current production rates, they are building approximately 10,000 planes monthly, more aircraft than our entire Air Force possessed at the beginning of this war. The room fell silent as veteran pilots and aircraft designers struggled to comprehend numbers that challenged every assumption about aviation manufacturing and industrial capability. These were men who understood aircraft production through European traditions of precision craftsmanship, individual attention to detail, and quality over quantity approaches that had characterized German aviation excellence. They had no way of knowing they were witnessing the greatest aviation production miracle in human history, or that American assembly line aircraft would soon darken European skies in formations so massive they would fundamentally redefine the mathematics of aerial warfare through overwhelming numerical superiority. If you want to discover more incredible stories of how American industrial supremacy stunned the world during World War II, make sure to subscribe to our channel and hit that notification bell. Reichsmarschall Hermann Göring stood before his aviation ministry staff in Berlin, radiating confidence about Luftwaffe superiority that would soon be shattered by American production capabilities he had never imagined possible. As architect of German air power and veteran of World War I aerial combat, Göring embodied Nazi assumptions about aviation excellence that emphasized individual pilot skill, aircraft quality, and tactical innovation over industrial abundance. The German aviation industry that Göring commanded represented centuries of engineering excellence and craftsmanship tradition that had made German aircraft synonymous with technical superiority and manufacturing precision. Companies like Messerschmitt, Focke-Wulf, and Junkers produced fighters and bombers using methods that prioritized individual attention, custom fitting, and quality control that reflected broader German cultural values about industrial excellence. Intelligence reports about American aircraft production reached German aviation headquarters through sources that consistently underestimated democratic industrial capabilities and worker productivity. Nazi analysts described American factories as chaotic operations plagued by labor disputes, racial tensions, and individualistic attitudes that prevented the collective discipline necessary for sophisticated aircraft manufacturing, requiring precision engineering and systematic assembly. The cultural foundation of German aviation confidence rested on pilot training programs that emphasized individual excellence, tactical innovation, and warrior spirit that Nazi ideology claimed could overcome any material disadvantage through superior skill and fighting dedication. German aces like Werner Mulders and Adolf Galland had achieved remarkable success through personal ability rather than numerical advantage. Technical comparisons between German and American aircraft seemed to validate Nazi assumptions about aviation superiority. German fighters featured sophisticated engineering, precision manufacturing, and advanced aerodynamics that reflected the highest standards of aviation design. American aircraft appeared crude and simplified by comparison, suggesting industrial approaches that sacrificed quality for quantity production methods. Economic analysis conducted by German planners revealed American industry divided between civilian aircraft production and limited military manufacturing, indicating a nation unprepared for the total aviation mobilization that German organization had achieved through systematic conversion of civilian facilities to military requirements and ideological commitment to air power development. The social organization of German aviation reflected Nazi principles about hierarchy, technical expertise, and individual excellence that appeared superior to American democratic methods, emphasizing mass production over craftsmanship quality. German aircraft workers followed systematic procedures that maintained precision standards, while American methods allegedly sacrificed technical requirements for production speed. Personal experiences of German aviation experts who had observed American aircraft factories before the war reinforced stereotypes about democratic inefficiency and worker capabilities. Reports described American aviation manufacturing as dependent on raw material abundance, rather than the systematic technical excellence that resource-constrained Germany had developed through necessity and superior engineering tradition. Military successes during 1940 to 1941 seemed to validate German assumptions about the relationship between aircraft quality and combat effectiveness. Luftwaffe forces had achieved air superiority over multiple enemies through tactical excellence and equipment advantages that reflected superior aviation manufacturing and pilot training methods that democratic societies allegedly couldn't match. Strategic planning for prolonged aerial warfare assumed German aviation advantages would enable victory through superior aircraft performance, pilot skill, and tactical innovation that would overcome any quantitative disadvantages through qualitative superiority. The mathematical possibilities of American mass aircraft production had never been seriously considered by German planners who measured aviation capability through traditional European standards of craftsmanship and individual excellence. The delusion was complete, and reality would soon deliver devastating consequences that German aviation could never have anticipated through their limited understanding of American industrial democracy. Henry J. Kaiser walked through his Richmond shipyard in California before dawn on March 15, 1943. Then drove 20 minutes to inspect progress at the Douglas aircraft plant, where his production expertise was being applied to aviation manufacturing. The man who had revolutionized shipbuilding was about to demonstrate that American mass production techniques could transform aircraft manufacturing from artisanal craft to systematic industrial process. The conversion of American industry to aircraft production represented the largest manufacturing transformation in aviation history, with automobile companies, appliance manufacturers, and consumer goods producers applying mass production expertise to military aviation requirements. General Motors, Ford, and Chrysler adapted assembly line methods to aircraft manufacturing while maintaining civilian production capabilities that German planners had never considered mathematically possible. Douglas Aircraft's Long Beach facility exemplified American aviation production philosophy that emphasized standardization, interchangeable parts, and systematic assembly over individual craftsmanship and custom fitting. The C-47 Skytrain transport aircraft rolled off assembly lines using automotive techniques adapted for aviation requirements, achieving production rates that European aircraft manufacturers considered impossible without compromising flight safety. Workforce transformation in American aviation included unprecedented numbers of women entering skilled manufacturing positions traditionally reserved for male craftsmen. Rosie Cohen welded aircraft fuselage sections with precision that matched traditional methods while bringing efficiency. Innovations from her civilian work experience that enhanced production speed without sacrificing quality standards required for flight operations. The economic incentives of competitive capitalism encouraged aviation manufacturers to achieve cost reduction and production acceleration through systematic innovation rather than administrative direction or ideological motivation. American companies competed for military contracts through delivery schedules, cost effectiveness, and quality improvements that created continuous pressure for manufacturing optimization and technological advancement. Supply chain coordination across American aviation industry demonstrated logistical capabilities that European manufacturing had never attempted to develop at continental scale. Aluminum from the Pacific Northwest, engines from the Midwest, and precision instruments from specialized manufacturers flowed into assembly plants through transportation networks that maintained delivery schedules despite geographic distances and competing military requirements. Quality control procedures developed for consumer goods. Manufacturing proved applicable to aircraft production through statistical methods that ensured flight safety across thousands of units. American aviation manufacturing achieved reliability through systematic testing and continuous inspection rather than individual examination, enabling mass production without sacrificing performance requirements that combat effectiveness demanded. Innovation acceleration continued throughout production expansion rather than being sacrificed for quantity targets, contradicting European assumptions about incompatibility between development work and manufacturing schedules. American engineers continuously improved aircraft design, production methods, and component specifications while maintaining delivery rates that traditional manufacturing approaches couldn't achieve. International cooperation through Lend-Lease programs demonstrated American confidence in production capacity that exceeded domestic military requirements by enormous margins. British, Soviet, and other Allied forces received American aircraft that enhanced collective air power while maintaining surplus production that indicated industrial capabilities far beyond German intelligence estimates. The night shift at Boeing's Seattle facility produced B-17 Flying Fortress bombers using round-the-clock operations that maintained continuous assembly flow without the downtime that European factories accepted as inevitable limitations. American aviation production was achieving mathematical impossibilities according to traditional manufacturing assumptions about industrial capacity and resource allocation requirements. The arsenal of democracy had taken flight through systematic organization, competitive innovation, and inclusive participation that would soon overwhelm German aviation through abundance, rather than requiring tactical excellence or individual superiority to achieve air power dominance across global theaters of operation. October 1943. The Willow Run plant in Michigan achieved what aviation experts had declared impossible: complete B-24 Liberator heavy bombers rolling off the assembly line every 63 minutes, 24 hours a day, 7 days a week. Henry Ford's automotive production genius, applied to aviation manufacturing, was creating strategic bomber capabilities that exceeded total German heavy bomber production by ratios that redefined aerial warfare mathematics. Statistical analysis of American aircraft production revealed numbers that challenged German understanding of industrial capacity and resource allocation possibilities. American factories were producing over 8,000 military aircraft monthly, while maintaining civilian aviation manufacturing and supporting global Allied air forces through Lend-Lease programs that indicated surplus capacity beyond any European calculation. The North American aviation plant in Inglewood, California, demonstrated systematic assembly techniques that produced P-51 Mustang fighters faster than German forces could destroy them in combat. Production schedules achieved one complete fighter aircraft every 4 hours and 20 minutes, creating tactical situations where numerical superiority overwhelmed individual pilot advantages through systematic abundance rather than technical excellence. Labor productivity measurements contradicted German assumptions about democratic worker discipline and manufacturing efficiency. American aviation workers produced military aircraft at rates exceeding German output, despite shorter working hours, better wages, and safety conditions that emphasized worker welfare rather than production maximization through authoritarian control and ideological pressure. Resource utilization efficiency demonstrated American advantages in raw material processing and manufacturing optimization that European aviation industry had never achieved through traditional methods. American aluminum production, precision manufacturing, and component assembly consumed fewer resources per aircraft while achieving superior performance characteristics through systematic quality control and continuous process improvement. The economic mathematics of American aircraft production achieved cost reduction through volume manufacturing that enabled superior performance at lower unit prices than German production methods could accomplish through precision craftsmanship and individual attention. Mass production had solved cost-effectiveness challenges that traditional aviation manufacturing had never addressed through organizational innovation. Supply chain integration across American aviation industry created logistical advantages that European manufacturing networks had never attempted to develop at continental scale. Component delivery schedules, raw material flow, and finished aircraft distribution operated with systematic coordination that maintained production rates despite geographic distances that would have disrupted European manufacturing systems. Quality assurance through statistical sampling maintained flight safety standards across tens of thousands of units while identifying manufacturing defects before they affected combat effectiveness. American aircraft achieved reliability through systematic testing rather than individual inspection, proving that mass production methods could exceed craftsmanship quality through scientific approaches to aviation manufacturing. Innovation integration during production operations contradicted German beliefs about incompatibility between development work and systematic manufacturing schedules. American engineers continuously improved aircraft specifications while maintaining assembly line operations, demonstrating that competitive pressure could accelerate technological advancement rather than requiring separate research and development cycles. International production sharing through Allied cooperation provided American aircraft to global partners while maintaining domestic manufacturing superiority that ensured continued technological leadership. Democratic values had created sustainable alliance systems that enhanced collective air power through systematic generosity rather than exploitative relationships. The maintenance infrastructure supporting American aircraft operations included spare parts production, technical manuals, and replacement procedures that enabled sustained combat effectiveness at scales German logistics had never contemplated. American abundance extended beyond initial production to encompass systematic support that maintained operational capability throughout extended campaigns. Mathematical certainty was replacing tactical speculation as the decisive factor in aerial warfare, with American production capacity creating numerical advantages that German pilot skill couldn't overcome through individual excellence or technical superiority alone in combat operations. January 1944. Intelligence reports reaching Luftwaffe headquarters documented American aircraft production that had achieved statistical impossibility. Over 96,000 military aircraft manufactured in 1943 alone, exceeding total German aviation production since 1935. The numbers were so overwhelming that German military planners initially dismissed them as Allied propaganda before multiple independent sources confirmed mathematical reality that had rendered Luftwaffe capabilities obsolete. Generaloberst Hans Jeschonek, Chief of Staff of the Luftwaffe, studied American production figures that violated every principle of aviation manufacturing that German military tradition had developed through decades of systematic engineering and aircraft development. American democracy had achieved industrial mobilization that exceeded German capabilities by factors that made continued air warfare mathematically impossible rather than merely strategically challenging. The psychological transformation of German aviation leadership reflected comprehensive reassessment of American capabilities that extended beyond aircraft production to encompass systematic advantages in pilot training, technological innovation, and resource allocation that competitive democracy had achieved through methods that authoritarian control had never contemplated. Technical analysis of captured American aircraft revealed manufacturing quality that equaled German precision while being produced in quantities that German aviation industry couldn't approach through any conceivable resource allocation or organizational improvement. Mass production had achieved reliability standards through systematic methods that individual craftsmanship had accomplished only through personal attention and custom manufacturing. Economic calculations demonstrated American cost advantages that decreased as production volumes increased, contradicting German assumptions about the relationship between quantity and expense in advanced aviation manufacturing. Democratic capitalism had achieved industrial efficiency through competitive optimization that command economy methods had never accomplished through administrative direction. Strategic implications extended beyond immediate military disadvantages to encompass post-war global relationships that would be determined by industrial capabilities rather than military victories achieved through tactical excellence or pilot superiority. American aircraft production represented systematic advantages that would influence international aviation competition for decades following military conflicts. The workforce development that enabled American success challenged German assumptions about aviation manufacturing requirements and social organization. Women, minorities, and civilian workers had contributed to aircraft production through systematic inclusion that enhanced rather than compromised manufacturing effectiveness, contradicting authoritarian beliefs about technical expertise and hierarchical control. Innovation acceleration throughout mass production had demonstrated American ability to improve aircraft design while maintaining assembly schedules that traditional methods couldn't achieve through individual craftsmanship or precision manufacturing approaches. Democratic competition had encouraged continuous improvement that exceeded German technological development despite superior theoretical engineering knowledge. International cooperation through aircraft sharing had provided American planes to Allied forces while maintaining domestic production superiority that indicated industrial capacity far beyond German intelligence estimates. Democratic values had created sustainable partnerships that enhanced collective air power through systematic abundance rather than exploitative relationships. Quality control achievements in mass production had exceeded German individual inspection standards while enabling systematic output that traditional aviation manufacturing considered impossible without compromising flight safety requirements. Statistical sampling and continuous testing had solved quality assurance problems that individual expertise had never adequately addressed. The revelation that darkened German skies demonstrated American systematic advantages in aviation democracy that would reshape global air power through competitive innovation, inclusive participation, and scientific management that had proven superior to authoritarian control through measurable results that rendered ideological assumptions obsolete. German confidence had been shattered as mathematical reality replaced theoretical superiority, proving that democratic aviation organization could achieve systematic advantages that cultural traditions couldn't match through any organizational methods or ideological motivation available to authoritarian systems. May 8, 1945. As Nazi Germany surrendered unconditionally, the final accounting of American aircraft production revealed numbers that had redefined aviation history. 324,750 military aircraft manufactured during World War II, including fighters, bombers, transports, and trainers that collectively exceeded all other nations' aviation production combined while maintaining civilian aircraft manufacturing and global airline operations. Hermann Göring, captured by Allied forces and awaiting trial at Nuremberg, reflected on his catastrophic miscalculation of American aviation capabilities. The crude American aircraft that Nazi leadership had dismissed had overwhelmed German air defenses through systematic abundance that rendered individual pilot skill and aircraft quality strategically irrelevant in aerial warfare. The human cost of German aviation arrogance became apparent through systematic analysis of production statistics that revealed American aviation democracy had achieved victory through industrial abundance rather than requiring brutal sacrifice that totalitarian systems had demanded from their populations. American aviation workers had earned higher wages, worked better conditions, and maintained civilian prosperity while producing aircraft that exceeded Axis capabilities. Technical achievements in American aviation production had revolutionized manufacturing methods that would influence global aerospace industry for generations through systematic approaches to quality control, worker training, and continuous improvement. Democratic competition had encouraged innovation that exceeded traditional European methods through scientific management rather than cultural tradition or ideological control. Economic efficiency of American aircraft production had achieved cost advantages through volume manufacturing that enabled superior performance at lower unit prices than traditional craftsmanship could accomplish through individual attention and precision methods. Competitive capitalism had proven more effective than command economy organization for systematic resource allocation and technological development in aviation manufacturing. The workforce diversity that enabled American success had demonstrated social advantages of democratic inclusion over hierarchical restrictions that authoritarian ideology had promoted. Women, minorities, and civilian workers had contributed technical skills and innovative approaches that enhanced aviation manufacturing effectiveness through systematic participation rather than ideological conformity or traditional exclusion. Innovation integration throughout mass production had contradicted authoritarian assumptions about the relationship between quantity emphasis and technological advancement in aviation development. American engineers had achieved continuous improvement while maintaining production schedules through competitive methods that centralized planning had never accomplished through administrative control or ideological direction. International cooperation through aircraft production sharing had established American leadership in global aviation systems that enhanced collective security through systematic abundance rather than exploitative relationships. Democratic values had created sustainable partnerships that would influence post-war aviation development and international cooperation through competitive collaboration rather than authoritarian domination. Strategic planning that exceeded immediate military requirements had demonstrated American confidence in continued aviation leadership through competitive innovation and systematic organization. Aircraft production capacity had enabled rapid conversion to civilian aviation that maintained employment and economic prosperity during peacetime transition while establishing global aviation dominance. The educational systems that produced American aviation workers had created human capital advantages through democratic participation and individual opportunity rather than hierarchical control and ideological indoctrination. Technical knowledge, innovative thinking, and systematic problem-solving had emerged from competitive education rather than authoritarian instruction or traditional apprenticeship methods. Quality control achievements through mass production had established aviation standards that exceeded traditional craftsmanship while enabling systematic output that would dominate global aerospace markets through scientific methods rather than cultural heritage or ideological superiority claims. The aircraft that rolled off American assembly lines had carried more than military firepower. They had demonstrated systematic advantages of democratic society that would reshape global aviation through industrial capability, technological innovation, and inclusive prosperity that authoritarian systems could never match through coercive control or ideological superiority. If this incredible story of how American aviation democracy overwhelmed German air power through industrial abundance amazed you, make sure to subscribe to our channel for more untold tales of democratic innovation triumphing over authoritarian arrogance.